Okay, welcome to Tungal online classes. In previous video, we had discussed the concept of free body diagram. So, free body diagram means the graphical representation of various forces acting on the body. So, that is known as the free body diagram. Okay, so today we are going to discuss the new concept. So, that is Atwood machine or mass pulley problem. Okay, see here. It is used to determine the acceleration due to gravity at a given place. Atwood machine, it is used to determine the acceleration due to gravity at a given place. And it is very simple machine, and this machine is consist of the two bodies of masses. It consists of the two bodies of masses m1 and m2 are connected with the help of the light string. And this light string that is passing over the frictionless pulley. This light string, it is passing over the frictionless pulley. Here frictionless pulley, so then the tension inside the string at every point is same. After that, this frictionless pulley, it is fixed to the ceiling or fixed to the rigid support. Okay, see here. So, in this case, it consists of the two bodies of masses m1 and m2, and these two are connected with the help of a light string. It is passing over the frictionless pulley, and here the pulley is frictionless, so then tension inside the string, that is same at every point. Okay, see here the condition is if m1 is greater than m2. If m1 is greater than m2 means the mass of a first body is more comparing to the mass of the second body. If the mass of a first body is more means the weight of this body is also more comparing to the weight of the second body. So, due to that one, so this body is moving in the downward direction, at the same time this body is moving in the upward direction. Okay, see here, in this case the weight of the first body is more comparing to the weight of the second body. If the weight of the first body is more means this body is moving in the downward direction and this body is moving in the upward direction. Okay, see here. Then we are going to find out what is the tension inside, what is the direction of a tension inside the string. Okay, see here. So, this is a point of contact and this is a point of contact between the string and the body B, and this is a point of contact between the string and the body A. So, already we know that the direction of a tension, it is always away from the point of contact. Here this is a point of contact means this is a direction of a tension, and here this is a point of contact and this is a direction of a tension. So, here is also we are going to determine what is the acceleration of this system, what is the acceleration of this system, and what is the tension inside the string, what is the tension inside the string. Okay. So, to find out the acceleration of this system, first we have to draw the free body diagram for body A and for body B. Okay, see here, for body A, so consider this is a point object. So, this is a point object here. So, in this case, the weight of this body is acting in the downward direction. For body A, the weight of the body is acting in the downward direction, that is W, right. Next, the tension, it is acting in upward direction. So, tension, it is acting in upward direction. Tension, it is acting in upward direction. Okay, see here. So, in this case, the body is moving in this direction, the direction of the acceleration is in this direction. So, in this case, the body is moving in the upward direction, then the direction of acceleration is upward direction. So, here the weight of the first body is more, that is why this body is moving in the downward direction, then the direction of acceleration is also in downward direction. In this case, the body is moving in the upward direction and this is the direction of acceleration here, right. So, here the free body diagram for body A, first one is the weight is acting in the downward direction and the tension is acting in the upward direction. So, here the direction of acceleration of the first body of mass is, that is m1, right. Okay. So, next for second body B, first we are considering that the object as a point mass, right. Okay. So, next the first force, the weight is acting in the downward direction, and the tension is acting in upward direction, and this is the direction of the acceleration, that is the direction of acceleration. Okay. So, from free body diagram of a body A. So here the net force acting on this system, that is equal to, so in this case the weight of the body is more comparing to the tension, that's why this body is moving in the downward direction. So then the net force is equal to, maximum force minus minimum force. So in this case this is the maximum force, due to that one the body is moving in the downward direction. Then net force is equal to weight minus tension. The net force is equal to maximum force minus minimum force here. In this case the weight of the body is more comparing to the tension. So the net force acting on this body is equal to weight minus tension. Here the net force is nothing but the product of mass into acceleration. Here the mass of the first body is, that is m1, and acceleration is, that is a. Next W means that is the weight of this body, it is the product of mass into acceleration due to gravity. Here the mass of the first body is m1 and acceleration due to gravity is g, minus tension, right. So this is our equation number 1. So next, from this diagram, from free body diagram of body B. So in this case the net force acting on this system, so that is net force is equal to, so in this case this body is moving in upward direction. So then here the tension is more comparing to the weight of the body. Okay, so here in this case this body is moving in upward direction means here the tension inside the string, that is more comparing to the weight of this body. Then the net force acting on this body is, that is tension minus weight. So the net force is nothing but it is a product of mass into acceleration. Here the mass of a second body is m2. So here the net force is, that is m2 into a, that is equal to tension T as it is, minus weight is nothing but that is m1 into g. So this is our equation number 2. Okay. So next we are going to solve equation number 1 and equation number 2. Solve equation number 1 and equation number 2. Okay, see here, write on the equation number 1 here, that is m1a, that is equal to m1g minus tension T, and the equation number 2 is, that is m2a, that is equal to tension minus m1 into g, so this is m2 into g. Okay, see here. So from the free body diagram of a body B, that is net force equal to tension minus weight. The net force is nothing but mass into acceleration, that is m2 into a, that is equal to t. Then weight of this body is, that is mass into acceleration due to gravity. Mass of second body is m2 into acceleration due to gravity. Okay, see here. So add these two equations here. So this is m1a and this is m2a, that is m1a plus m2a, that is equal to, here this is a plus t minus t get cancelled, the remaining is, that is m1g minus m2g, minus m2g. Okay, in this case take a common here, then it becomes m1 plus m2, that is equal to, here take g common, means that is m1 minus m2. Okay, so from this relation acceleration is equal to g into m1 minus m2 divided by the total mass is m1 plus m2. So this formula we are used to find out the acceleration of the system, that is a is equal to g into bracket of m1 minus m2 divided by m1 plus m2. So then we are going to find out the tension inside the string. So this is the acceleration value here, that is a is equal to g bracket of m1 minus m2 divided by m1 plus m2. So here this is the a value, a is equal to g bracket of m1 minus m2 divided by m1 plus m2. So this is our equation number 3. So next we are going to find out what is the tension developed inside the string. So for that one we have to substitute a value either in equation number 1 or in equation number 2. So here we are going to substitute the A value in equation number 1. So here substitute A value in equation number 1. Okay, see here. So then from equation number 1, that is M1A is equal to M1G minus tension. Here we want the tension value. T is equal to M1G minus M1A. Take M1 common. So I substitute the A value here. Then it becomes M1G minus, the A value is G bracket of M1 minus M2 divided by total mass is M1 plus M2. Okay, see here, in this case take G is a common, so then it becomes M1G bracket of 1 minus M1 minus M2 divided by M1 plus M2. Okay, see here. So then take LCM here, then it becomes M1G bracket of M1 plus M2. Take this minus sign inside, then it becomes M1 minus into minus, it becomes M2 plus M2 whole divided by M1 plus M2. So in this case, this is a plus M and this is a minus M, M1, both are get cancelled. The remaining is M2 plus M2 divided by M1 plus M2. Okay, so here in this case, this is a plus M and this is a minus M, both are get cancelled. The remaining is M2 plus M2 divided by M1 plus M2. So M2 plus M2 means that is 2M2. So this is equal to, so tension, that is T is equal to 2 into M1 into M2 G divided by M1 plus M2. So this formula we are used to find out tension inside the string, that is T is equal to 2 M1 into M2 into G divided by M1 plus M2. So this is about the Atwood machine or mass pulley problem. See here, Atwood machine, it is used to determine the acceleration due to gravity at a given place, and it is very simple machine. It consists of the two bodies of masses M1 and M2 are connected with the help of a light string that is passing over the frictionless pulley, right? The first one, we have to draw the free body diagram for body A and body B. Here the condition is the mass of first body is more comparing to the mass of a second body if M1 is greater than M2. Okay, so after that, so here mass of the first body is more comparing to the mass of the second body means this body is moving in the downward direction and this body is moving in the upward direction. So afterwards we are going to draw the free body diagram for body A and body B. So after that, the net force acting on this body A, that is weight minus tension. Here the weight is more comparing to the tension inside the string. So after that, substitute the values here. So next, from free body diagram of a body B, so then net force equal to T minus, that is T minus weight. So here the tension in the string inside the string, it is more comparing to the weight of that body. So then net force equal to tension minus weight. So next, simplify this one, we will get the acceleration value here. Substitute the acceleration value either in equation number 1 or in equation number 2, you will get the tension. So tension, that is T is equal to 2 M1 M2G divided by M1 plus M2. Here the note point here, if a force on a clamp or a string holding the pulley, so that means, so what is the tension developed inside this string? Okay, see here, we will redraw that diagram. So this is the pulley, frictionless pulley, and this is a clamp or the string, and this is the string that is passing over the frictionless pulley. So this portion of the diagram, right? See here, in this case, the direction of a tension inside the string is, this is a point of contact, so it is always away from the point of contact, and here is also same, it is away from the point of contact. And here the tension inside this clamp or the string, so this is a point of contact means this is a direction of a tension inside that clamp or the string. So here we will take that one is T1, right? Okay, so draw the free body diagram for this body. So consider this body as a point object, and here the one force is acting in upward direction, that is T1 is acting in upward direction, and these two forces are acting in the downward direction, that is 2t. These two forces are acting in the downward direction, that is 2t. So from this one, the net force acting on the system, that is equal to, so T1 minus, that is 2t. So in this case, this frictionless pulley, it is at stationary or rest. If it is at rest means acceleration is 0. If acceleration is 0 means the net force acting on that string, that is m, the net force acting on this system, that is m into a, that is equal to T1 minus 2t. Here acceleration value is 0, 0 into net term is 0, then it becomes T1 minus 2t. It becomes T1 minus 2t, because the acceleration value is 0, mass into acceleration is 0 means then it becomes 0 is equal to T1 minus 2t. So T1, take the T1 term this side, T1 is equal to, that is 2t. So that means the tension developed inside this string, that is the 2 times of a tension developed inside this light string. See here, they are given a problem. So in this problem, they are given a diagram. So this is a mass pulley problem. So here they are given the mass of a first body is 3 kg and mass of a second body is 2 kg, and these two bodies are connected with the help of a light string. It is passing over the frictionless pulley, right? So here they are given the mass of the two bodies is given. So here we are going to find out what is the acceleration of this system and what is the tension inside this light string, and then what is the tension developed inside the clamp or in this string. Okay, the first one, here the condition is the mass of first body is more comparing to the mass of the second body. In that case, this body is moving in this direction and this is the direction of a acceleration. At the same time, this body is moving in the upward direction, this is the direction of acceleration. Okay, see here. So after that, we are going to draw the free body diagram for body A and the body B. So here for body A, free body diagram for body A, first consider this as a point object, right? The first one, the weight of the body is acting in the downward direction, that is W, and here tension is acting in the upward direction. So this is a free body diagram for body A. So here the direction of acceleration is in this direction. Okay, so next for body B, free body diagram for body B, here this is a point object, and in this case the weight is acting in the downward direction and tension, it is acting in the upward direction. So here this is a weight in downward direction, tension is in upward direction. Okay, so next we will write the equation here, right? The net force acting on the system, that is the net force acting on the system, that is equal to, in this case the body is moving in the downward direction, so then weight minus tension, weight minus tension. Here the net force is nothing but product of mass into acceleration. Here let us assume that the mass of the first body is m1 and the mass of a second body is m2. So this is m1a, that is equal to m1 into g minus tension, right? So next similarly from body B. So next here the net force acting on the system. So in this case this body is moving in the upward direction. So then the tension inside the string is more comparing to the weight of this body. So then net force is equal to tension minus weight. Here the mass of a second body is, that is m2 into a, that is equal to tension as it is minus W is, it is a product of mass into acceleration due to gravity. So this is our equation number 1 and this is our equation number 2. Okay, so from equation number 1, so here from equation number 1, m1 into a. So what is the m1 value here? That is 3 kg. m1 is equal to 3 kg. m2 is equal to, that is 2 kg. Okay, say m1 into a. So that is 3 into a, that is equal to m1 into g. m1 value is, that is 3 kg. Here g value is, take g equal to 10 meter per second square. So then g is 10 minus tension. Okay, see here this is 3 into a as it is into 30 minus t. So this is our equation number 3, right? So next, from equation number 2, from equation number 2, so here m2 into a, here m2 value is 2, 2a, that is equal to tension as it is T minus m2 into g, m2 value is 2, g value is 10. So this is equal to 2a is equal to T minus 20. This is our equation number 4. Solve equation number 3 and 4 here, that is okay. Equation number 3 is 3a is equal to 30 minus t, and this is 2a is equal to t minus 20. So solve this one here, 3 plus 2. So this is 3 plus 2, that is 5a, that is equal to plus t minus t, both are get cancelled, 30 minus 20, that is 10. Then acceleration of the system is a is equal to 10 divided by 5, that is equal to 2 meter per second square, that is 2 meter per second square. So this is acceleration of this system. If you know the acceleration, you can easily find out the tension, right? So from this relation, substitute a value in equation number 3. Substitute a value in equation number 3. Equation number 3. Here 3, what is the a value here? A value is 2, substitute here, that is 2 is equal to 30 minus t. So here 3 into 2, that is 6, 30 minus t, then t is equal to 30 minus of 6, t is equal to 24 Newton. Tension, that is equal to 24 Newton. Okay. So then T1, the next one is the T1. So already we know that T1, that is equal to 2 times of T. T1 is equal to 2. T value is, that is 24, that is equal to 48 Newton. 48 Newton. Okay. See here, the first one, the acceleration of the system is 2 meter per second square, and tension is 24 Newton, and the tension inside this clamp, that is 48 Newton. See here, this is a homework problem. So in this case they are given mass is 8 kg, m1 value, and m2 value is, that is 12 kg. Here the condition is m2 is greater than m1. So in this case this body is moving in the downward direction and this body is moving in the upward direction. Then find out acceleration, tension inside the string, and the T1 tension inside the clamp. Take g is equal to 10 meter per second square. The next case, if the two bodies are connected with the help of a light string, the one body is on a horizontal surface and another body hanging vertically. Okay, see here. So consider this is a horizontal surface. So the one body of mass m1, it is placed on a horizontal surface, smooth horizontal surface, and the another body of mass, that is m2, this is another body of mass m2, and these two bodies are connected with the help of a light string, that is passing over the frictionless pulley. So here in this problem, the two bodies of masses m1 and m2 are connected with the help of a light string. So that string is passing over the frictionless pulley. So here is also we are going to find out what is the acceleration of this system and what is the tension developed inside the string. Okay, see here, the first one, here the first body of mass is m1 and second body mass is m2 and is connected by the light string. So here we are going to find out what is the direction of a tension inside the string here. So already we know that this is a point of contact, means the direction of a tension, it is always away from the point of contact, and here is also the direction of a tension, it is away from the point of contact. Okay, see here, first we are going to draw free body diagram for body A and body B. So this is a body A and this is the body B. Okay, see here, for body A, first consider this is a point object. So in this case the weight of the object is acting in the downward direction, and the normal reaction it is acting in the upward direction, and the tension is acting in this direction. So tension acting in this direction. This is a free body diagram of body A. So its mass is m1. Next, for free body diagram of a body B. So here consider this a point object. In this case the weight is acting in the downward direction, and the tension it is acting in the upward direction. The tension is acting in the upward direction. So the condition is that is m2 is greater than m1. Condition is m2 is greater than m1. So that means the mass of this body is more comparing to the mass of first body. So due to that one, this body is moving in the downward direction and this body is moving along the horizontal direction. Okay, so here from this diagram, so then net force acting on the system. So the net force acting on the system, that is equal to, so here the tension it is acting in this direction, the net force is equal to tension. So net force is nothing but the product of mass into acceleration, that is m1 into a is equal to tension. So this is our equation number 1. So in this case that body is moving along the horizontal direction. So there is a no motion of the body in the vertical direction. So here there is a no motion of the body along the vertical direction. So then the the normal acting on this body, that is balanced by the weight of that body. So that is n is equal to w. So here the body will not move along the vertical direction. So then the weight of the body is balanced by the normal force acting on that body. Okay. So next, from free body diagram of a body A. So here the m2 value is more, and this is the direction of acceleration here. Then the net force acting on this system, the net force acting on this system, that is equal to, here the weight is more comparing to the tension, that is weight minus tension, weight minus tension. So net force is nothing but product of mass into acceleration, that is m2 into a is equal to m2 into g minus t. So this is our equation number 2. So next, substitute t value in equation number 2. Substitute t value in equation number 2. T value in equation number 2. Okay, what is the equation number 2 here? That is m2 into a, that is equal to m2 into g minus t. What is the t value here? T value is, that is m1a. So substitute here, that is m2 into a is equal to m2 into g minus t value is, that is m1a. T value is m1a. So next, take this term this side, then it becomes m1a plus m2a, that is equal to m2g. Then take a common, then it becomes m1 plus m2, that is equal to m2 into g. So then acceleration is equal to m2 into g whole divided by total mass, that is m1 plus m2. So this formula we are used to find out the acceleration of the system, that is m2 into g divided by m1 plus m2. Okay, next we are going to find out what is the tension. What is the tension inside the string? Okay, so here substitute a value in equation number 1. Substitute a value in equation number 1. Substitute a value in equation number 1. So what is the equation number 1 here? That is t is equal to m1 into a. Here substitute the a value. That a value is m2 into g divided by total mass. That is m2 into g divided by total mass. That is m1 plus m2. So this is a tension developed inside the string. So this is the acceleration of the system, and that is a tension in the string. Okay, see here. So in this problem they are given the two bodies. The first body is on horizontal surface and the another body is hanging vertically. Okay, so in this problem they are given the two bodies. The one body is on a horizontal surface and the another body is hanging vertically, and these two bodies are connected with the help of a light string, right? Okay, so here is also we are going to find out the acceleration and the tension. First we have to draw the free body diagram for body A and the body B. this is a free body diagram for body A and this is a free body diagram for body B, and the equation is the net force that is equal to tension, and here the net force equal to weight minus tension. So net force is nothing but M2 into A, that is equal to weight is M2 into G minus tension. So after that, substitute T value in this equation, we will get the acceleration of that system. A is equal to M2G divided by M1 plus M2. So next, substitute A value in equation number 1, we will get the tension value T is equal to M1 into M2G divided by M1 plus M2. Okay, see here, the next one, the force on pulley due to string. The force on this pulley due to string. Okay, see here, the first find out what is the direction of a tension. Here, this is a point of contact means this is a direction of a tension, and this is a point of contact means this is the direction of a tension. Okay, see here, we will redraw that diagram. So this is the pulley and this is a string, right? So here, this is the direction of a tension here, and this is also direction of a tension. So here tension is a vector quantity. So this is a one vector quantity and this is another vector quantity. Law of vector addition, that is R is equal to P square plus Q square plus 2PQ cos theta. 2PQ cos theta. So let us assume that this is a P vector and this is a Q vector. Here the both the vector value are same. The P value is also same and the Q value is also same. Then the angle between these two vector is, that is 90 degree. So substitute here, then force acting on the pulley, that is equal to under root of P value is T, that is T square plus 2T cos of 90, 2T square cos of 90, cos 90 value is 0, so this whole term becomes 0, then F is equal to, that is under root of T square plus T square, that is equal to F is equal to root 2T square, so that is equal to root 2 into T. So this much of force exerted by string on the pulley. So that is F is equal to under root of 2 into T. See, in this problem they are given the mass of first body is given, mass of second body is given. The mass of first body is 2 kg, mass of second body is 6 kg. Then find out the acceleration of the system and tension inside the string. Okay, first we have to draw the free body diagram for body A and body B. For body A, so consider this is a point object. Here the weight of the body is acting in the downward direction and normal reaction is acting in the upward direction. Next, this is the direction of tension. So this is the free body diagram of a body A. Similarly, the free body diagram of a body B, right? See here, consider this is a point object and here the weight is acting in the downward direction and the tension is acting in the upward direction. The tension is acting in the upward direction. Okay, see here. So from this diagram, the net force acting on the system, that is equal to tension. The net force on the system, that is equal to tension. So there is no other forces acting along the horizontal direction. So then the net force is nothing but it is the product of mass into acceleration, that is M1 into A, that is equal to T, right? Or T is equal to M1 into A, right? So what is the M1 value here? That is T is equal to 2 into A. Okay, the next. So from this diagram, net force acting on the system, that is equal to weight minus tension. Here net force is nothing but M2 into A, that is equal to M2 into G minus, that is T, as it is. Here the T value is M1A. So T value is, that is M1A. Here T value is M1A. Okay, substitute the values here. So here M2 value is, that is 6 kg, 6A, that is equal to 6G minus G is, take 10. So G value is 10 minus M1. M1 value is 2A, right? Simplify this one. Take 2 this side. 6 plus 2 means, that is 8A, that is equal to 60. Then A is equal to 60 divided by 8. That is 7.5 meter per second square. 7.5 meter per second square. So then substitute A value in this equation, you will get the tension. So here acceleration value is 7.5, then substitute the A value in this equation, then the tension inside the string, that is T is equal to 2 into 7.5, that is equal to 2 into 7.5 means that is 15 Newton. So this is a tension developed inside the string, right?